Hello, Algebra 2 Geo students. This is our topic, which is labeled the algebra of functions, and it contains that and some other things with functions. We'll probably do it in two pieces, so there will likely be a second video. The algebra of functions is about doing adding and subtracting, multiplying and dividing instead of with variables with functions. And there's four rules which correspond exactly to the four operations that we're familiar with. A lot of this is just like terminology more than anything else. But if you ever see this, f plus g in parentheses, and then of x, what that means is you add f of x and g of x together. It's just this is just a different way to write this. F plus g of x equals f of x plus g of x. And you can do this same kind of thing for all four operations, adding, subtracting, multiplying, and dividing. So for subtracting, you would do f minus g of x. We would call that f of x minus g of x. So these things are exactly equivalent. But sometimes it's written this way, so I want you to be able to understand the difference between these two things, or understand that they are the same. So we got adding, subtracting. You can also do f times g of x, which is often just written like fg, that means multiplying. And that's, of course, f of x times g of x. So multiplying, multiplying. And the final one, which you may have guessed by now, is f divided by g of x is f of x divided by g of x. And this last one assumes that g of x is not equal to 0, because you can't have a 0 on the bottom of a fraction. So four operations, adding, subtracting, multiplying, and dividing, four different ways to write these combinations of functions. And f and g are just any old functions. So to see this as an example and kind of to show you that it works, here's a problem where they give you two functions, f of x and g of x. And they say find f of 2 plus g of 2. So you just do them separately. F of 2 means you put a 2 in everywhere you see an x in the function f of x. So f of 2 would be 2 plus 4, which is 6, clearly. And then that's f of 2. For g of 2, I put a 2 for every x I see in the function g of x. So right there, I would say g of 2 is 2 squared plus 1, which is 5. And now the problem says to find f of 2 plus g of 2. So now I have all the information I need to do that. F of 2 plus g of 2. F of 2 is 6, and g of 2 is 5. That equals 11. So this is f of 2 plus g of 2. And the second part is the kind of thing I was saying. Like it's saying now if we add f of x and g of x together first, we could say f of x is x plus 4. And g of x is x squared plus 1. If I add those together, right, it says f of x plus g of x, I get one x squared term. There's one x term, so plus x. Sorry, one x term, and then 4 plus 1 is 5. I get x squared plus x plus 5. And so this is what this is like the first thing I wrote on the first page. This is f plus g of x. This is the combination of f and g with adding. If I want to do f plus g of 2 now, I just plug a 2 in here, wherever I see an x. So I put a 2 there and a 2 there, and I get 2 squared plus 2 plus 5. Which 4 plus 2 is 6, plus 5 is 11, that's 11. The whole point here is that this 11 is the same as that 11. Like it doesn't matter whether you plug the numbers in first and then add the functions together, or you add the functions together and then plug in the number. And to a large extent, I don't care which order you do it in, as long as you understand what this notation means, that it means you add them together and plug in the number. You can add them together, you can plug in the number first, like I did up here, and add those numbers, or you can add the functions together and then plug in the number once. Whichever one you think is easier. I really don't care which is which, as long as you understand the distinction between them. Oh boy, this one already has a bunch of writing on it. So same kind of question here, find f plus g of 3. So for this first one, since it just says find f plus g of 3, it doesn't give me any doesn't have to do anything else. I could do f of 3 and then g of 3 and then add the numbers together. Or I could add f of x and g of x together and then plug in the 3. I'm going to do it that second way. So I'm going to do f of x plus g of x. So that's x squared minus x plus x plus 2, f plus g. And that's x1, x squared term is left. The minus x and the plus x cancel out. And I'm left with x squared plus 2. And then if I want f plus g of 3, I got to plug a 3 in for x. So just so we are all keeping track, this is f plus g of x right here. This is the two functions added together with an x still in it. But I want x equal to 3, and so I get 3 squared plus 2, which is 11. That's the same as the first problem that we did, but that's just a coincidence. Part B here is just, here they ask you to find this thing first, so you have to do it the way I just did, and then you're going to plug in a -1 once you do that. So this one says f minus g, so I'll do it in 2 colors. We'll call f the blue one, and we'll call g the green one. So f of x is x squared minus x, and then I subtract the green one, which is x plus 2. It's important that you put the parentheses so you remember to subtract both the x and the 2. And that's going to give me, there's only one x squared term, so that just sits there. Minus x minus x. That's 2 minus x's, so minus 2x. And then minus 2. Minus 2. It's important that you remember to distribute that negative to both those terms. And now it said find f minus g of -1. So I want x equal -1. So I'm going to do -1 squared minus 2 times -1 minus 2, -1. So this is a 1. -1 squared is 1. And then plus 2 because it's negative, and then minus 2, and that equals 1. That's my answer. So that's how you do these when you have to. This one they requested here that I find this thing first. So this is right here is f minus g of x. And this is f minus g of -1. And here they want f, that's supposed to be I think it's supposed to be a fraction line there. So it's f over g of x, f divided by g of x. So that's x squared minus x over x plus 2. That's f divided by g of x. And then they want me to plug in a -4. So I can do that too. -4 squared minus -4 all over -4 plus 2. -4 squared is 16, and then it's like a plus 4 because it's minus a minus. 16 plus 4 is 20. The bottom is -2, and that gives me -10. So these should be, when these show up on assessments, you should be pretty comfortable with doing that. Just turning this into this and turning this division into that. Pretty straightforward. Nothing too tricky there. This composition is kind of a big thing. Y'all are going to be seeing this repeatedly throughout this unit and through next year in pre-cal and in calculus and every math class day from now on. You're going to have to do this thing called composition of functions. This is like putting one function into another. We're all very comfortable, like when I say plug a -4 in here, you just put a -4 where the x's are. Composition is the same thing, except now instead of putting -4 or a number in for x, we're going to put a whole other function in for x. We're going to see how to do this in a minute. I want you to know that there's 2 ways to write this. There's the good way, which looks like this. This says f of g of x. That's how you would read that. This is f of g of x. And it means you put the function g of x inside the x's of f of x. The other way to write this, which I think is silly, uses this like little symbol that's like an open circle. It looks like an O kind of sometimes, but it's not. It's like a little, it's like a multiplication dot, but it's like open. These things mean exactly the same thing. This means put g inside of f, and this means put g inside of f. I like this notation better because g is sitting inside of f where you would expect it to be sitting. And this is like, you have to know that this one goes in there, not the other way around. To me, this is more confusing. I'll write it this way sometimes because y'all will be taking standardized tests and it's sometimes written that way on those. But when I see this written, I tend to just switch it to this right away. I don't like this notation very much. I think it's kind of clunky. So So we'll do these ones, and then we'll get to the tables and the graphs in the next video, because those are a little different. So composition, this is a pretty big deal. So this f open circle g of x, remember, I'm going to rewrite this like this, f of g of x. This means we're going to put g of x inside of f of x. So f of g of x equals, so what is g of x in this problem? It's right there. G of x is x squared. So f of x, 2x minus 1. So it's 2 times, and then the thing that goes where the x is now, remember, that's like if I said what's f of 10, you'd put a 10 where the x is. If I said what's f of 20, you'd put a 20 where the x is. Now I'm saying what's f of g of x, so you put the g of x where the x was. So now instead of an x here, I'm going to write x squared, because that's g of x, and then minus 1. And this is just equal to 2x squared minus 1. So I replaced the x in this function with this function. Sometimes people will write it like, the next step they'll write f of x squared. They'll do that, because like this is g of x, right? These things are the same. And then it helps you to see this is the thing that goes where the x was in the original function. So this is the answer. This is f of g of x. This is the composition of f and g. And so you could do this in the other order too. In this one, they want you to do it both ways. They want you to do g of f of x and then f of g of x. And this is the kind where I think it's really convenient. It's really helpful to write it like this. This is g of f of x. And this is f of g of x. So let's start with g of f, right? Because that was the first one they said. So let's make this one blue and this one red. So the first problem is g of f of x. So I do g of f of x. And that is equal to, you can also call that g of 2x plus 3. Like, I'm going to put this in everywhere I see an x in this one. So that's 5 times, let me do that in red because it's still g. 5 times 2x plus 3 plus 1. And then underneath that, we have 2 times 2x plus 3 minus 3. You see, like the f of x just goes right in here where the x's were. 5 times 2x is 10x. 5 times 3 is 15, plus 1 is 16. And then 2 times 2x is 4x. 2 times 3 is 6, minus 3 is 3. So this is the answer for g of f of x. And for f of g of x, we're going to do the same thing, except now we're going to switch the order we do it in. So we're going to do f of g of x. And that equals, f is this function, 2 times x plus 3. So it's going to be 2 times, but now instead of x, remember, instead of x, I'm plugging in g of x, so I do 5x plus 1 over 2x minus 3. And then the rest of f was 2 times x plus 3. And then there's not a lot of simplifying you can do here. You can multiply the 2. Remember, this 2 is like 2 over 1. So I can multiply the 2 to the top of this fraction. 10x plus 2 over 2x minus 3 plus 3. In theory, you could add these two things together, but it's not going to get much easier if you do that, so I'm just going to leave it like that. The important thing here is that you know which of these functions to put into the other one based on the order these things come in. And like I said, I think this notation is much more, it's natural, it's much more practical than this weird little O thing that they do. So I'm going to break this here, and we are going to do the last page in the next video. Hopefully it'll be a little shorter. Bye.